Hello everyone and welcome to Devoxx Ukraine. I really hope you enjoy it as of now. And we will speak about open source project who eBPF. The user program will generate BPF bytecode that will be loaded inside the kernel. BPF that then can run this bytecode, and you can just have like outputs, statistics, maps of the eBPF call. So when you are using eBPF to run Falco and to install Falco inside the cluster, it's how it's works. So basically, you have your instrumented application, like for example your container. You have an eBPF hook that intercepts the calls and send it to sysdic through a ring buffer, because you have lots of information running on the ring buffer. You will have like high volume data, event stream, and you will then have low volume data on the eBPF map to respond to the eBPF program. So this is how Falco can intercept syscall inside eBPF. The overall architecture of Falco is like that. So you have a YAML file, YAML rule that can be used to feed the engine. You will have libsys ENSP to be called the underlying engine, and you can call just libscap that will be intercept syscall. And then you have the ring buffer and the kernel module with Falco. And the engine will get input from the Kubernetes audit events and will output whatever you want, like gRPC, std out, and whatever you want. Okay, so now how we can install Falco on our cluster. So this is very simple. It's a Helm chart. So you have the one-liner here to install Falco. So you just install Falco with eBPF enabled, and for the sake of the demonstration, I will just deactivate the Docker, because you know that in recent versions of Kubernetes, Docker is being deprecated and it's been replaced by containerd. So I will just deactivate Docker for the sake of the demo. So with this one-liner, we have a running Falco daemon set that is run on all the cluster and all the machines. Just before going to the demo, Falco runs as a daemon set on the cluster, because Falco basically intercepts syscalls, and when you are auto-scaling your cluster, like going from 3 nodes to 5 nodes, 6 nodes, 7 nodes, or whatever, you will want to have Falco inside each of this node, and this is why a daemon set is more convenient than a pod. So this is how Falco is installed. So first we will do a little demo. I'm sorry for the GIF that is being just hashed, but we will do a little demo for this first part, and just run a container and just connect to the container on this running a shell inside the container, and just see what the logs look like. So I have lots of cheat sheet here. So I will just show you the pods that is running now. So you have Falco here that is running inside the container, the cluster, sorry. The cluster has 3 nodes. That's why we have 3 Falco pods. And we will see afterwards why we have Falco sidekicks, but it's another demo. So you have the first Falco running on the cluster. And we will just start a new container with Alpine and just let Alpine run. If we are going to see what containers are running inside the cluster, we will see that we have Alpine running and it's running for 5 minutes. And now we are going to execute a shell inside this container and just see the uptime of the container or uptime of the system. So you see that the system has been running for 33 days and you have lots of information. And now we are going to see if Falco intercepts this running container, running shell inside the container. So we just see the logs. So we have lots of logs. And somewhere we can see that it started a call somewhere. And lots of logs. Lots of logs generated by Falco. We should see, okay, so we should see that there is a running container somewhere, but I don't see it. I see lots of notice. Okay, so never mind. It should be because I am restricted to namespaces. If we are going to see, okay, so I'm going to just get the pods and real quick, going to see if there is logs. Okay, container. Sorry. Okay. Preamp bits. Previous container started. So this is not this one. I will take the second one. So here it is. This is my logs I have inside Falco. The notice shell was spawned in the container with Untitled terminal. User root, user login UID 1, Kate's NS default, pod Alpine, process launch is SHC uptime. So you can see that Falco has generated logs based on what I have done, and you can see that it's been logged. So this is the first demo I wanted to show you. I will just destroy the running Alpine. Okay. So this is the first demo. Okay, so cool. You have intercept running shell inside the container, and there is some logs produced by Falco. But what about production? So in production, you will want to externalize this log somewhere else, like a remote logging system, or syslog, for example, or a remote secure logging system with ELK in mind, Logstash, Kibana, whatever you want. And of course, you will want to send these events through a CM with SCC QRadar to be able to detect connection, to detect an anomaly inside your containers, and we will have to add something more to be able to send these events. So let me introduce a second project around Falco that is called Falco Sidekicks. That's why you have running pods with Falco Sidekicks running inside the namespace. And Sidekicks basically just get the events from Falco and can just send it somewhere else. In chat, for example, in metrics, observability, logs, object storage, email, web, notifications, Slack, whatever, and something that will be using after. For example, you can just send events through serverless syscalls are being called, and by which system. About that, it's assert the stream against a powerful rule engine. So you have like more than 100 rules at the moment, and every syscalls are assert against this rule engine, and it generates an alert when a rule is violated, and this alert can be used to log somewhere in the system, for example, syslog, Loki, ELK, stuff like that, or it can be used somewhere else to respond in real time to hacking on the container. So what Falco checks? Falco checks lots of things. For example, it checks that you are running privileged containers and you escalate this privileged container. You are changing namespaces inside the container with tools like setns. You change some binaries in /usr/bin with /usr/sbin. Or you can execute SSH binaries such as SSH, STP, SFTP. You can detect also that you are launching a shell binary, and for example, if you are launching a shell binary, you can just intercept that and say that there is something wrong because nobody should launch a shell binary inside the container. So if you are detecting a shell binary that is being launched, it's because something is wrong with your containers. Or you can also intercept binaries like shadow util or passwd, because if you are going to change the password in the container, it's not important. But if you are using it on VMs, it can be really important if you are going to change the password. So this is how Falco works, and now we are going to see how the rules are being defined. So a rule is basically a YAML file containing three types of elements. One, the rule itself, and the condition under which an alert should be generated. The second can be macros, so it's a little bit of snippet that can be used inside rules and even other macros. And of course, there is a third element that is lists. That's the collection of items that can be used in rules, macros, or other lists. So a simple rule can be something like that. So here you have a rule detecting a running shell in containers. So there is the name of the rule, shell in containers, the description, notice shell activity within the container, the condition when the rule are being triggered, and when the alert is being generated. So if, for example, your container is called exec v syscall, and the directory and containers ID is different to the host, and the proc name is bash, for example, it should generate an alert. And the output is just a log in a file, and the output will be shell in the container, user, the username, and the container ID, the container name also, the shell, the parent, the command line, and it's a warning. So if you are going to just connect to a container, run a shell inside a container, it will generate this kind of line inside the log. And Falco, of course, can generate an alert. So I told you that Falco is generated a line inside a log, it's in a file. You can also redirect the alert on the standard output, on a syslog, for example, on a spawn program, on a HTTP endpoint, or a client through the gRPC API. And here at the right of the screen, you can see that an alert has been generated by someone launching the binary hack, and it's being generated inside. Here it's Slack, I think, but you can see that you have lots of information on the alert. So how Falco does that, and how Falco can intercept syscalls on a running container. So you have three different installations of Falco. The first one and the default installation is a kernel module. So you can just load the module inside the kernel, and Falco will run inside the kernel and can intercept syscall easily. And you can just install the module with Debian RPM package, and it's something like just apt get install Falco or yum install Falco. So it's really convenient when you have access to a kernel module, and you can just put a kernel, put a module inside the kernel. If, for example, your kernel is statically compiled and you don't allow module, you can also leverage on eBPF probe, and is the second installation of Falco, but it's only supported by recent kernels. So I think it's around 4.x or 5.x that is being supported. And it's really convenient when you can't inject a kernel module inside the kernel. For example, GKE doesn't support kernel module, so it will launch an eBPF probe and just intercept call running with eBPF. And of course, the third one, the third installation, you have little binary called pdig that can be used in user space, and it's really like STRAS, for example, that intercepts syscalls, but it's really slow. It's using ptras, for example, in the user space, and it's really when other methods don't work. So you have three different ways of install Falco. The first one is kernel module, of course. The second one is eBPF probe, and the third one is user space instrumentation. Just a little explanation of what a syscall is to the people that is not used to use syscall. So syscall is basically kernel space done by some library, some binary inside the user space. So first, when you are writing like a C program, like test.c here, you can call a function in the libc that is called fwrite. So you can just call fwrite hello on the output, and you can just write hello on a file. So fwrite is implemented inside libc and is essentially a wrapper around write. And write is the function that will call the process, the syscall ID1, and cause the processor to switch to kernel level. So basically, when you are writing a program, you call fwrite that will call fwrite in glibc, that is a wrapper inside write, and write will load the syscall ID1 and switch to kernel space. And inside the kernel space, processor feeds the syscall's ID1 to the syscall table, extract the function pointer at offset 1 and calls it. So basically, you just call the sys_write, that is a syscall. You have lots of syscall that can be supported by Falco. I think it's around more than 100, so it's really lots of syscalls. And it's basically how Falco can intercept syscalls. So when using eBPF, so eBPF is like a program inside the kernel that can intercept lots of things, and you can program the kernel with eBPF. So when you are using has been released on the CNCF called Falco, and who has been developed by SysDig. So let me introduce myself. So I'm Laurent Grangeau. I'm a cloud solution architect at Sogeti, a subsidiary of Capgemini, and I think there is one Capgemini in Ukraine. And of course, we are recruiting experts on clouds, GCP, Azure, AWS. So you can go see how our site to see our open jobs. So why I'm speaking now about security on clusters? Because if you are watching the news from every website on the internet, you will see that there is lots of clusters unsecured, and lots of clusters has been hacked to crypto mine bitcoins, to launch DDoS attacks to other websites, and there is lots of misconfigured Kubernetes clusters that are open on internet. For example, if you create a new cluster on AKS, on GKE, on AWS, it's open by default on internet, and of course it's secured with a PKI certificates. But if you are going to deploy like an old version of Drupal, for example, you can be hacked with Drupal, and then you can go to the containers and then go to Kubernetes and then exploit the Kubernetes. So that's why we have to enforce the context. On virtual machines, it's easy because you can use SE Linux, and you can deploy like bounded context on SE Linux, but it's really difficult to implement. As of now, I don't see any companies that are really implemented it well. So it's not being used, and it's always used like an audit tool because you have like permission. So it's not enforced, it's permissive. Of course, you have AppArmor that is a lot easier to deploy, but it's based on the path of the binary. So if you move the binary from one path to another, AppArmor doesn't apply, so you can just run the binary by default with the permissions of the system. So on the screenshot here, you can see that we are protecting the /usr/bin/ping with the capability of netrow and setuid. But if you are going to move the ping binary to, for example, /usr/local/bin/ping, AppArmor doesn't apply. And of course, you have last one security tool called SecComp. And SecComp basically audits syslog and allow or deny syslog calls based on actions. And you will see that Falco really used this implementation of syscall and implementation of SecComp to allow or forbid what we are going to do in the cluster. You have also lots of audit log. For example, you can see that you have audit log with us/usr/sbin/group add run by someone somewhere, unconfined subject on SE Linux, and you can see that this log is redirected to the syslog, and you can outsource them on another system. So it really helps to do forensics if you are going to be hacked and to see what's going on in the system. And it will really helps if we can like just have some logs on Kubernetes like that. So which people are going to do something, and to have like a audit log of what's going on in the cluster. I just told you that we can be hacked by many means of attacks. So, for example, an old Drupal running on a cluster. We had a meetup last year, I think, with AWS, demonstrating an old Drupal running on a Kubernetes cluster. And by hacking the Drupal container, we can go to the Kubernetes cluster. We can go also to the machines running on AWS, and then you can call the metadata server and have like a key to be able to hack your AWS cluster. So it's really important to have like the latest update on your running container. You can also inject a command with env variable. If, for example, your container get an environment variable running inside your container, you can arbitrarily launch a binary, for example, a payload, a hacking payload, and then just run as the user inside the cluster, and it's 90% it's root, so you can just be admin on your cluster and be admin on your machine. So it's not a good way. And of course, you can have CVEs in your cluster, because Kubernetes is something that is constantly being updated and has been run of CVEs. So we have to ensure that everything is secured and everything is under control. So the best way to do that is we have to secure the syscalls of the kernel to be able to intercept syscalls and to enable or disable run on the syscall, and to be able to see on logs how we can leverage on that tooling. So here enters the Falco. Falco, so it's strengthen container security by running a module on the kernel and intercept syscalls. It reduces risk via immediate alerts. So it generates alerts, and these alerts can be applied on every system, like Elasticsearch, on Loki, on running a serverless engine, and we will do that in a moment. And of course, you can leverage on the most current detection rules. It's around, I think, 100 rules at the moment, and this is the best, the most common rule when we are hacked that is being applied. So Falco is an open source project created by Sysdig in 2016. It's open source, so you can go to github.com/Falco security/Falco to contribute and to see how Falco is being deployed and how Falco run, and how we can have some updates around that. It has been donated to the CNCF around 2019, I think, and it's been incubated to the CNCF as of now. It's coded in C++, so it's really low level programmation to be able to run the kernel. Like 1 or 2 months ago, it has more than 4,000 stars on GitHub. So it's being really watched by lots of people, and it has around 114 contributors, like 1 or 2 months ago. So it may have evolved. So basically, Falco is a security module that can be injected on the kernel inside your running cluster, and that will just see what syscalls are being called and what we can do with that. So it uses calls to secure and monitor our system. It can be run, of course, on Kubernetes, but it can also be run on virtual machines. And basically, it parses the Linux system calls from the kernel at runtime. So you can see what engine and just react to events. So if you are going to see how now the architecture is extended by the Falco sidekicks, so you have Kubernetes, of course. You have the eBPF probe or the module of the kernel. You have Falco here with the running pods. You have the rule engine here. You have the rule in YAML that is being injected to the engine. And Falco just send an event through the alerting system. And Falco sidekicks can just send whatever you want with gRPC, files, stdr, shell, HTTPS, what you want. So to install the Falco sidekicks, you just have to add inside your Helm Falco sidekick.enable again equal true, and we will add some more values around that to be able to have a web UI, a beautiful web UI, and to send events to Loki. Here I have some Loki installation already installed on the cluster, and Loki is basically ELK but free and done by Grafana Labs. That's why I'm using Loki. So here is the second demo, and we are going to just send the event to Loki and to see if we can detect the events done by Loki. So here we have, here we have installation of Loki. So you have FreeBit, Grafana, Prometheus running on the cluster. I will just get the secret from Grafana and just forward my installation. So now if I go to localhost 300, I think it's not 300. Why can't I just port forward? Okay. Lots of things that don't work. Just one sec. Crypto get SVC and space Loki stack. Loki Grafana service. Okay. So normally everything should be fine. I don't know why I can't connect to the cluster. Ah, that's okay. That's why. Okay, so if I go to the login, I can log to Grafana with the password. And we'll just zoom so you can see. Okay, so I have a Grafana dashboard, and basically I can go to explore and go with Loki and just run some query to see if there is something. Because the cluster already has been installed with Loki and Falco, there is something somewhere. So if I go to, I'm sorry. For example, Falco. You can see that there is lots of information already, and we have like std out, a shell was run. That's my shell that I've launched before. And if we are going to do a new demo, so I will going to launch a new container with a shell. So I will go with Alpine. Okay, Alpine is started. And now I will just see the content of etc shadow, sorry. And we are going to see if there is something. Okay, so I'm going to run it live. So I have the content of shadow, and you can see that lots of logs are being generated by Falco and being received by Loki. And so you can see that's my HC shadow here, content. Sensitive file open for reading by non-trusted program. And I have run cat/etc/shadow. So I have detected this running container and this running shell inside Loki. Okay, so that's how we can do log on a remote log, for example. And you have also an UI with Falco Sidekick that is running with UI, I think. Okay, so you have a beautiful UI with Falco Sidekicks, and you can see that rules are being triggered, like contact Kate's API server from containers, launch privileged container, read sensitive file untrusted, termination container, and you can just see the timeline. I prefer to send events through Loki because with Loki you can just have a remote Loki, more secure, and you can just have immutable logs and see how we can do like forensics, stuff like that. I will just stop my Alpine. Okay. So, okay, so now I can have events on my running cluster. I can log them to Loki. And now I propose you to react to these events and to create a response engine based on this event. As I told you before, Falco can send events through serverless framework like AWS Lambda, Kubeless, OpenFast, Fiction, Knative. And for the sake of the demo, I have chosen OpenFast because it's really convenient and really easy to install. It has been created by Alex Ellis, which resides in UK, and it's basically a function as a service inside the Kubernetes cluster. And of course, you can use lots of different language like Node.js, Python, Go, .NET, Rust, whatever you want. And it's really, really powerful, but really simple. And for the third demo, I will just upgrade Falco to be able to config a function name called Falco-pod-delete and react to this event. So basically what Falco does is send the events through Loki and through OpenFast to the function Falco-pod-delete. Okay, so this is the third demo and the most complex one. So OpenFast is already installed here. Just go back, already installed here. So there is lots of components of OpenFast, but basically it already runs. There is a portal from OpenFast. So if I go through this portal, you can see that, okay, you can see that there is lots of information. Just put in my password. And you can see that you can deploy a new function. So this is OpenFast, and you can just deploy your function, and it's being deployed on the cluster. Okay. And now I will just create a new function called Falco-pod-delete and just modify the source code to be able to react to events. And what will I do what I will do is to just get the event, detect the running containers, and just kick it, so destroy it. Because, for example, if you are being hacked, if we take Drupal, for example, if you are being hacked and Drupal is being hacked, the best way is to kill the pod, because you don't want Bitcoin mining on your running containers. You don't want your container to be a way of attack to your cluster. And if you kill the pod, you will rely on the mechanisms of Kubernetes to restart a new image that is being just pure and not being hacked. So I have installed Falco with my function name, falco-pod-delete. And you can see that if we are going to see the installation of Falco Sidekick, there is a lot of things. I have enabled some outputs like the web UI and OpenPath, for example. And you can see that there is lots of information, but we are going to see that later. Now I also apply a YAML file. So basically what I'm doing here is to create service accounts, okay, called falco-pod-delete on the openpath-fn namespace. And this service account just can get, list, or delete my pods. And I will basically just list my pod and react to events and delete my pod. And of course, I have some cluster role binding to bind the cluster role with the service account. So here I apply the YAML file. It has already been applied, so that's unchanged. And now I can create my function. So first, I will just pull the templates, the Go template middleware from the OpenPath. So everything is already done, and we have two templates, Golang HTTP, Golang middleware, and we will use the Golang middleware. So you have some templates by OpenPath that already has whatever you want to do a function in Go within the Docker file with Go mod, main.go, so the handler of the function, and we will just create a function based on that template. So if I go back to this one, I will create a new function here. So the function has already been created, so that's why you have some error message. And basically what I have is three things: the Go mod with all of my modules from Go, the GoSum, and of course the handler. And we will modify this handler to be able to react to events. What I have to do also is to modify a YAML file that is being generated by OpenPath called the function.yaml file, and basically change the gateway here. So this is my gateway from OpenPath. So this is my gateway here. Okay. Here we have the templates, the handler from Go, falco-pod-delete, my image with my prefix, because I will use Docker Hub and put the public image on the Docker Hub, and put some annotation to tell OpenPath to run this function with my service account I already created. So falco-pod-delete, and this function will just run with my service account. Okay, and now I will just modify my handler. So I already modified my handler, and basically what I'm doing is to get the configuration of the cluster to be able to delete my pod. and create a new client here in the initialization part. Next, I map the structure of the alert of Falco to a struct with the Go language. So you see that I map the alert output to the output of the event, the priority also, the rule, the time, and the output fields with container.id, container.image.repository, container.image.tag, and lots of things I have with the JSON from Falco. And now I will just whitelist some namespaces and pods that I don't want to be destroyed. Job system, kube public, kube not release, Falco, openfast, openfastfn, of course, and my here my login system. And now I create a handle that can get the request and react to events. What I'm doing now is to get the body, to unmarshal it to JSON, to the alert structure, and to get the pod name and the space that has been triggered. And here I see that if the namespace is not in a critical namespace or the pod is not in a critical pod, I can just delete the pod just fine. So I'm putting logs like deleting pods, pod name from namespace, and I'm just deleting the pod. And that's how we can react to events. For example, you can just put whatever you want in the function. But for now, we will just react to the deletion. And of course, I deploy it on openfast. So I already deployed it because it's really long to compile, to upload to Docker Hub, and to deploy it on the cluster. So everything has been done automatically. The container has been pushed, the image, sorry, has been pushed to my Docker Hub, and the function is being deployed here on the openfast portal, and you can see that Falco pod delete is already deployed. Okay. If we are going to see the openfastfn namespace, you can see that you have my two functions, node info that has been deployed by the portal, and Falco pod delete that has been deployed 33 seconds ago. And now I just restart my Alpine container. I will just generate a new cat/etc/shadow. So I'm going to see the content of etc/shadow. But now we are going to see if the pod is always running. So you can see that the pod is already terminating because Falco detects that something is wrong with the /etc/shadow, send the event to the namespace, the function, sorry, and the function destroy the running container. So imagine now you have like a Drupal running, being hacked to install Bitcoin mining or to install malicious binary. You can just react to this hacked container, and you can just terminate it. And if you are going to see now if containers is being run, so there is no container running inside the namespace. And if we are going to see if everything is fine, okay, maybe I have some typo. Okay, so we see that openfast has been called. The function is okay, and we have called the function falco-pod-delete.openfast-fn, and everything is fine. And if we are going to see the logs from the call, I'm sorry. What is the gateway? The gateway here is this gateway. Maybe if I'm okay. Okay, so you see that the function has been called 3 minutes ago, and everything is fine. Okay. Sorry. So in this demo, we have seen that we can just react to to events in real time, and we can just kill the pod based on the events we received. So what's next? As of now, 1 month ago, Falco announced the early access of plugins. So in the near future, you can just create some plugins, put some plugins inside Falco, and create a more modular system and experience that we have now. So in conclusion, we saw that Falco is a powerful DevSecOps tool to be able to react in real time to events on a Kubernetes cluster. I have done a little demo, but you can, of course, make it even bigger or running it in production. Falco is a de facto Kubernetes threat detection engine, and it's being used by more and more vendors. For example, AWS runs Falco inside their clusters to be able to send events to CloudWatch or to to Lambda. And you can integrate Falco into a rich ecosystem. And of course, it's not only Kubernetes, but it's also on VMs. So you can just mix VMs and Kubernetes all together, and you have a new tool to be able to detect what's going on in your systems with VMs and Kubernetes. So thank you very much. I really hope that you enjoy this presentation, and I wish you a pleasant Devoxx Ukraine. Thank you very much.
Thank you. Yeah, thank you, Laurent. Thank you for your interesting talk, and thank you for connecting to Devoxx Ukraine this year. So I invite you and participants to continue a live discussion in the Q&A room. So you can find the proper Q&A room in the Rocket platform. Yeah, just go to the discussion menu and join the Q&A. So thank you once again.
Thank you very much.
Yeah, have a great day.
Thank you, you too.